There we go. Have a pencil and a paper. It is not a mental math exercise. Now, you don't have calculators on your desk right now either. I'll go ahead and use my calculator, but when we go to work on them, you'll need a calculator because you do not want to get the numbers wrong. You never want to get the numbers wrong, but it's a if you don't check your work with your numbers, then there's no way you're going to know you're wrong. You know, there's no safety net immediately, so that's why you want to get it right the first time. You know how it is, measure twice, cut once. If you're into carpentry, you want to make sure your arithmetic is accurate, okay? So yesterday we did one of these right at the beginning. So if you're writing this down, please just write it as a long division problem. You don't have to write with the division sign with the two dots. I know there's a name for it, but I don't know what it is. Pickles. So we'll write it with the root. So you put your x squared plus 6 is your divisor. Then under it go the polynomial. So remember, they have to have a space for every power. This is 9x to the 4th plus x to the 3rd. Uh-oh, there is no x squared. So in my division problem, I put 0x squared. Then I go on my way, negative 5x and 72. We can't use synthetic division because we're dividing by an x squared polynomial. This is the divisor. Ends up right here. And now we're going to find the quotient. So I always ask myself, what times x squared is this first term, leading term there, the highest power, 9x to the 4th, I need a 9, and I need an x squared. So if I write it above the matching power, 9x squared times x squared gives me 9x to the 4th, so I know I did it right. So I do my multiplication, and then I take 9x squared times 6, and that's 54x squared. And I write it under like terms, and I say my little jingle. Ready? Draw the line, change the signs, add down. So these need to disappear. If you don't, you did something wrong. Bring down the next term. It's a 0 plus minus 54 minus 5x plus 72. Lost you. Okay, now I ask myself, what times x squared is x cubed? That is x. And I multiply. X times x squared is x cubed. X times 6 is 6x. I write it under the right terms, the like terms. Draw the line. Change the signs. Add down. Negative plus negative stays negative. Now I ask myself, what times x squared is negative 54x squared? Negative 54. Multiply. There's the one I don't want to, I did it this morning, so I know what it is, but you want to multiply 6 times negative 54 is negative 324. There we go. So I draw the line, change the signs, add down 396. Okay. Now I can't take something times x squared to get x. Well, I could, but it's a fraction, so that doesn't work for long division. This guy's the remainder. So he'll go in the remainder boxes. They already have the negatives in there in the story for you, so don't repeat that. Don't repeat the negatives. You get it wrong. So pay attention. Okay. Everybody get that? Everybody got the remainder written down because I had to move back up here. This guy is the quotient. And the result, they want us to write it in this order. They already have the divisor. Here's where the quotient goes. See, I'm not just making it up. It's all written up here. So I put the 9 where the x squared coefficient. They already have a plus x, so I don't have to type that. And they already have the minus, and I put in a 54. These two are being multiplied, and then over here I put my remainder. And the negative's already here, so I just put 11 and 396. Okay. That is the magic for long division. So we'll have a couple more before we're all done, but we will go back to synthetic here for the next question. Okay. Well, zoom out a little maybe. See everything? Okay. There it is. So you see the importance of the calculations, kind of a big deal. You just add it wrong and the whole thing's wrong. So we don't want that. We don't want that for you. And that's math. We have to pay attention to precision. No fudging. Okay. Now we're gonna explore the synthetic story again if you're ready. No protest? Okay. All right. So for number 6, you can write down the original or you can just write down the synthetic. It says, given a polynomial p of x, use synthetic division to divide by x minus a and obtain the quotient and the non-zero remainder. Enter the result in this form where you take the divisor times the quotient plus the remainder. Okay, so here we go. Where do I get my crow's nest number? They don't give it to me. But if you notice here, looking at this, what's A equal? That's what goes up here in the crow's nest. Crow's nest. What's being subtracted here? The number 5. Yes. The reason why it's 5 is because you want the value that makes this 0. So if I take x minus 5 equals 0, I add 5. So x equals part, no, that's not a 5. Ugh. Okay. A is 5, and that's x or a, x equals a equals 5. That's what we're trying to process here. So that's where we get a from. What makes this 0? Okay, so x is still crazy. Now we write down our coefficients. 7, it belongs to x to the third. 20 belongs to x squared. Negative 258 belongs to the x term, and negative 59 is the constant term. So because I have a power of 3, I need 4 values. If I didn't have coefficients, quote unquote, because this coefficient, constant, okay, 1, 2, 3, 4. If I didn't have 4, one of them has to be a 0. So everything's all accounted for. So if I'm missing powers, I need to put in a 0. But they're all here for this question, number 6. So remember the process. Drop the first number below the line. Multiply and put your product above the line. Add down below the line. Now that is, this is where you're going to need a calculator, right? Because nobody has 5 times 55 memorized. $275. It's positive times positive is positive. Another thing is going to be sneaky is your signs. Oh, they're going to be pickles. Okay, drop. Taking the difference here, I get a 17. Positive. Multiply. 85. And then minus the 59. Because it's negative. Okay, that guy's the remainder. That's what goes here. And then these become the coefficients of the quotient. So it's 7x squared plus 55x plus 17. So I can rewrite my results as a polynomial with one less power. Remember, I was dividing by x. So x cubed divided by x is x squared. Crazy, huh? So the 7, the 55, and the 17. So you always go one less here. How do I know what to put here? It's always one less than what you started with. That's why it's a, you can, synthetic division's only used for a linear divisor. This guy's only power of 1. That's a linear binomial. So that's, if you know the why behind what you're doing, you're more likely to remember how. The how's not bad, just remembering how. That is what's going to take for synthetic division, since it's brand new to your brain. Trying to help you see where the pieces fit together. Again, you just need to write down the synthetic part for number 7. If you want to. You can write it all down. That's okay. It says determine whether the given binomial, that's this guy, is a factor of the polynomial, this guy. So in order for it to be a factor, remember the remainder has to be 0. So in order for it to be a factor, the remainder is 0. And that's the cool thing about this synthetic division. You can find out quickly if that's a factor, and then you can factor higher degrees polynomial using this synthetic division. So crow's nest is a -2 because that's what makes that 0. My coefficients, 1 for x to the third, 2 for x squared, -1 for x, and -2 for the constant. See where I get my values, paying attention, watching? Some of you aren't, and you're going to be sorry. It's going to hurt you. So you have to go back and listen to this poor thing again. Okay. Draw the line, drop the first coefficient. Multiply, add, multiply, add, multiply, add. So yay! Remember that final value result is the remainder, and then it is a factor because the remainder is 0. Now they want you to factor this. So this guy is x squared plus 0x minus 1. And they're asking you to do something you did in the last lesson, and that is factor a difference of squares. They do have a drop-down menu here. So the remaining factors are, and I don't know which one comes first, the minus or the plus. But yeah, either way, they're the factors. And that is how you determine if a binomial is a factor of a polynomial. Okay? That's why this is important to be able to divide. It's just not an exercise in academia. It helps you factor polynomials, okay? Because there's not a, if I give you this, there could be a pattern. Yeah, there's a pattern. You could use grouping, but this might even be faster than grouping. Depends on your skills. Depends on your comfort level with synthetic division. More tools in the toolbox, the better skills you will have. Okay, got to know how to do the tools, all right? Okay, determine whether the given binomial is a factor of the polynomial. Hopefully you've put what makes x plus 5 0 in the crow's nest. Then you write your 8 goes to the x to the fourth. 49 is x to the third. Uh-oh, there's no x squareds, so I put 0. Negative 222x and minus 5. So because this is power 4, I need 5 values. 1, 2, 3, 4, 5. If I don't have 5 values, I did something wrong. And guys, this is such an easy mistake. You'll go through all this hard work and you'll forget that there's an exponent missing, and so you'll have to start all over again. So I'm trying to warn you about that so it doesn't catch you by surprise. Drop, multiply. That was tricky. Negative times positive is negative. Add, multiply, add. Negative times negative is positive. 225. Add, multiply, add. Then I always check my work. Negative 5 times 6 is negative 49. Negative 5 times 9 is negative 45. Negative 45. Negative 5 times negative 45 is 225. 3, negative, negative. Yep, everything's good. So the remainder is a negative 20. So it is not a factor because I need a 0 there for it to be a factor. So I can go on my merry way. That was fun. So you're good with drop, multiply, add, drop, multiply, add, multiply, add, multiply, add, multiply, add. Done. Fun stuff. Number 9, I have a 0 or 8 makes that a 0. 1, negative 20, 131, and negative 280. Everything's there. Power of 3, 1, 2, 3, 4 values. Synthetic division. Multiply, 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 we got ourselves a 0. Looks like a donut. I must be hungry. Or a bagel. Or an olive. How's that? So it is a factor. So now we get to factor this guy. Since I started with an x cubed, I divided by an x, I get an x squared left. And I don't have to write the 1 in front. Then it's minus 12x plus 35. Okay, this is a common trinomial. Since that's not a perfect square, I ask myself, factors of 35 when added give me a negative 12. So they both have to be negative. So negative 1 times negative 35 doesn't add up to a negative 12. Negative 2 doesn't go, 3 doesn't go, 4 doesn't go, 5 goes, and a negative 7. So yep, they add up to a negative 12. So that's what goes in your drop down. The remaining factors are, that's not a very good R, writing on the line here, parenthesis x minus 5 and x minus 7. There we go. Halfway through. Nope, not quite. Next problem will be halfway through. You guys either get it or you're not paying attention. I need questions if we are in the dark. Today's your day to understand or ask questions. That's where learning begins, in the question zone. Determine if the given binomial is a factor. So I have to divide synthetically because that's a power of 1 and write my coefficients 2, negative 10, 6, and negative 26. 3, 2, 1, blast off. Power of 3, I need 4 numbers. Always cover yourself there. Bring down the first coefficient, multiply, write your product above the line in the next column. Add the 2 together, multiply, add the 2 together, multiply. Right? I've got all positives going on there. So the remainder is 4. Now you're thinking, Well, if they don't ask for factors, it means it's not a factor. But you got to figure out what the remainder is. That's the trick to these questions. So because they don't ask for other factors, you know your answer is going to be an is not. But you got to find this number. That's what's going to take the process of division. And you know, we are in the land of Oz. They write these questions, like I couldn't come up with a question like this just standing here. You know, they have to remember, keep the end in mind, what they want the result to be, and then they work backwards and build the polynomial. So, yeah, math book authors are a gift. We don't have to make up our own problems. Okay, ready for the process to continue? This one's just a synthetic substitution again. They just went back to the beginning. We get to put in a -2. See, because this is not a factor, it's a value. It is a. We don't have to change the signs on it. We just use it as it is. Remember, if they give you the factor, you have to write the opposite of what you see. If they just give you a value, you just march on with your 1, 4, 2, -21. Power of 3, I need 4 values here. We're good. Remember, if you don't see 1, it is a 1. If you see a subtraction, it's a -1. Be ready for that. Okay. Oh, pickles. Drop, multiply, add, multiply, add, multiply, add. So that was a nice reprieve from the long division. I think that might be what's coming next. Maybe. I don't know. We'll see. That's the remainder. That's what they want to know. Okay? You guys feeling it? I hope. Get in the game? Oh, yeah, long division. Woo-wee. Look at this. What a sweetheart. Here we go. Give yourself plenty of space. We'll start here at the edge. Writing our long division means a division roof. X squared plus 2x plus 6.5. Thankfully, we've got decimals. This guy's going to be a long one. How do I know? Because it has a power of 4. So that means I need to fill in the space with zeros. So x to the 4th plus 0x to the 3rd plus 0x squared, I'm trying to squeeze it in here, minus 31x minus 15.75. So that wasn't so bad. So x squared times what is x to the 4th? X squared. 2x times x squared is 2x cubed. And that's 6.5 x squared. So I multiplied this guy times x squared, got x to the 4th, x to the 3rd, x squared. Draw the line, change the signs, add down. brings what negative? Bring down the rest. Times a negative 2. Looks like x. Minus 2x. I need a negative 2 and I need an x for it to equal this. Okay, negative 2 times 6 is a negative 13, 6 and a half, sorry, negative 13x. Draw the line, change the signs. Everybody goes positive. So these two disappear. This is a negative 2.5x squared. That's 18 negative. And a negative 15.75. Almost done. Now I multiply by a negative 2.5. That'd be a minus 5x. And then 2.5 times 6.5 is a big bad that's negative, that's positive, negative 16.25. Hopefully just draw the line, change the signs is your magic to success. There's no such thing as magic, right? That's a plus. Okay, that's a negative 13x, and 16.25 is positive, minus 15.75 is positive 0.5. So it should fit in here. See, the 13 goes up there, 0.5. That's the remainder. And up here, they already have the x squared. Yeah, I just need to pop a 2 in there. They already have the minus. And then I need to put the decimal 2.5. Okay. So you should be able to finish through number 12 on your homework. I can get that in a one frame, at least the division problem. Capture that for posterity. So what was hard? Decimals, probably, right? They make you kind of crazy. Yay, technology. Call it a class period. Thank you. I'm going to stop it. If you're ready.